my screen with you. Share. All right, wait, this is where I always screw up. Hold up. Wait a minute. See, this is where it happens. This is where it happens for me. Wait a minute. I can't move it over. Uh-oh. Because I see it saying share, 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 share. But no. I did this before. And I don't know what I did then. And I don't know what I did now. See? Yeah. All right. So wait a minute. Let me cancel this. All right. Now let me try to share. There's some chatting going on. Yes. 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 I agree. Yep. It hurts my back too sometimes. And then I just come in and get me a cup of tea. Ah, now we're ready. Okay. So, our checkpoint 2 was about matching a histogram to a box plot. So, which two graphs represented the same data? So again, the notes that I wanted to stress about each of these, you can tell by looking at a histogram its shape, right? That's not the hard part. I think the more difficult part is looking at the box plots and and their characteristics, because again, remember, this course is about looking at data and critically analyzing what you see. So in this left skewed box plot, look at it the same way as if it were a graph. So if the tail is on the left, then the long whisker of the box plot is on the left. That gives you the cue that it is left skewed. So remember, if you don't have that in your notes, I want you to draw this box plot. I want you to pay attention to the fact that the median of the data is closer to the median of the upper end of the data. So your Q2 value is closer to your Q3 value. So those are the two characteristics that you look for in a box plot if it is left skewed. The long left whisker and excuse me, and the median being closer, the median of the data, Q2, being closer to the median of the upper end of the data, the Q3 value. If a box plot is symmetric, then everything is even. We can actually split the box plot in half and fold it over, and left side will look exactly like right side. So if it's symmetric, the whiskers are about the same length, and the Q2 value is equidistant or in the middle of or equal distance from both the median of the lower end, Q1, and the median of the upper end, Q2. And then for right skewed, again, if the graph is right skewed, we know that the tail is on the right, the data has been pushed left. So the same thing here. The longer tail is on the right, and the Q2 value, the median of the data set, is closer to the lower end or closer to the Q1 value, the median of the lower end of the data. So make sure that you have this little diagram in your notes. It will be of a pearl. So, Destiny, you have this? Do you have this? if you do not do one or the other. Either take a screenshot of it, and to screenshot, remember you hit Control and the button over the number 6. Or again, just sketch it. And in your sketch, I would suggest that you also include the, excuse me, the distributions up top. I know that they're gonna say, I thought it was a snow day. No, you didn't. You're not going outside. Let me know when you have it, ladies.
I got it.
Okay. Let me know when you get it. Oh, you know what? I never thought to do that. I'll have to remember to change that. Okay. Ooh, excuse me. Have you got it? I can't see the chat, so you know your silence means yes. Okay. So now, in making the comparisons, again, you want to kind of see if you can find any of these 4 things. So check the shape. Well, again, it is always easiest to see the shape of a histogram. Okay, so we see the shape of the histogram. We look for we can see in the histogram, before we even look at the box plot, we see in the histogram, we see what it looks like. So we can determine the shape, right? So we know, what's the shape? Don't all speak at once. Y'all know it's only 4 of us. Who?
Skew left.
Think about tail. The tail tells the skew. Where's the tail? Left side or right side?
Right.
Exactly. So therefore, it is skewed, yes, and it is skewed right. So we know that that's what this shape is, right? We could see the maximum, the minimum and maximum value. So we know that the minimum is 0. And we know that the maximum of the body, the main body of data, is a little more than 10, but less than 15. And we can also kind of, if you did the first cool down, ouch. If you did the first cool down, remember the median, when a data set is skewed, when a data set is skewed, we know that the median is just at our 50% mark. So when we look at this set of data, we see that the first bar is 40. It counts for 40 people. We are trying to find the median, which means we just need to get to 50, right? So if we have 40 in this first tower alone, in this first bar alone, we gonna need a little bit out of this second bar to get to 50. So we got 40 here. So we gonna have to take 10 of this 28 and get to our 50. We understand we understand that? Again, the median is 50%. So they gave us these values up at the top, and that is what is going to help us estimate the median. Because again, the median is the 50% mark. It's not going to necessarily be even, just 50%. So if we have 40 here, we need 10 of this 28 to get to our 50. So that means the median is going to be somewhere between this, it is going to be somewhere in this second bar. You understand? Does that make sense to you?
Yeah.
Okay. So now that means that our median, and again, they counted by, it's real crazy. They counted by 2s, but they represented 5s, multiples of 5. So this is 2, 4, 6, 8, 10, 12. So that's something else. You know, you sometimes may have to figure out what the scale is, but it's all good. So now we know then that our median is going to fall somewhere between 2 and 4. And then look for outliers. The outliers are anything that is not connected to the main body of the data. So here, our main body of data goes from 0 to 12. And then we have this sitting out here. This sitting out here at 14 to 16, that's considered an outlier. Okay? Because it lies outside of the main body of the data. So in our box plot, now let's look for those things. Well, maybe we can't determine the shape yet. So we're going to leave that for a minute. Now, remember, if you may see the box plot horizontally, which is how we have grown accustomed to seeing it, or you may see it this way, which is vertically. Same difference. Remember, the bottom will be your minimum. The top will be your maximum. The line in the middle is always your median. And then remember, you go, so this is minimum, Q1, Q2, Q3, maximum. And then anything here, in this instance, this little circle represents our outlier. Okay? So now, we might not know the shape yet, but we can check the max and min. So we can see that the minimum is down here, which they probably assume to be 0, because you can't touch the end of the graph of the box. We can see that the maximum is 12. So we can see our maximum is 12. So it's working there so far. Now, estimate the median. Well, when we looked at this, we said the median is going to be between 2 and 4. And look at this. The median is between 2 and 4. And then outliers. This is the outlier, and here is where the outlier is noted. Okay? So we can now go back to those little notes I just said So in your notes, we talked about, or I said to you, the left whisker longer than the right whisker, or the right whisker longer than the left. Well, if the orientation of the box plot is split, then if the upper whisker is longer than the lower whisker, then we could say that it is skewed right. Okay, because then we'll check. And also we see that our Q2 value, the median of the data set, is closer to the lower end's median, or the median of the lower end. Okay, so again, your task is to critically analyze what you see. Okay, so you might want to, that's your checklist, so to speak. All right, let's look at another one. Now this one, I just chose this to emphasize the way outliers are denoted. So here, again, if we look at shape, this is the body, the main body of the data. So when we look at shape, it's going this way. Okay, so we can see the push is left, meaning the tail would be on the right. The maximum terms, they went by 10,000s. So 10,000, 20,000, 30,000, 40,000, 50,000, 60,000. So we see that the max and min are 0 and 60,000. We can estimate the median. Again, this is also a lesson in reading a graph. So here, it's more than 15, less than 20. So we would estimate here that, let's say we estimate this to be 18. And then we estimate this to be, I don't know what you say, 8. But I don't know, it might be some documentation up here. But again, we know that the data is skewed right. And so 50% of the data will fall in this second bar. But again, I chose this one to emphasize the outliers. You see how these lie outside? They lie far away from the bulk of the data. This is how it's noted. So again, it's left skewed, but this one, it's right skewed, but it's right skewed with outliers. So outliers are normally, again, noted with circles. However, sometimes they may use an X. It will all depend on who the author of the book is. Okay? Does that make sense to you? We're going to see. All right, let's match them up. Again, critically analyze what you see. Use your notes. Remember tomorrow, ladies and gentlemen, we have all school assembly at 11:30. I just had to throw it out there when I remember. Okay. All right, you gotta look at it. So now, remember if you need to turn or translate, for those of you who've had me before, if you need to translate, okay, so if you need to take the vertical presentation and turn it horizontal, remember, the bottom is the lower end of your graph. So you will be turning it clockwise.
This in Summit.
No, I snatched this from somewhere else, but your second checkpoint in Summit, you were making matches. You were matching. This was the task. That's why we're going over it now, because we are then going to look at checkpoints 2 and 3.
Okay.
Oh yeah, we're making good time. So let's look at A. In looking at histogram A, let's talk about the shape. We have left skewed, right skewed, or symmetric. How would you describe it?
We don't see a shape.
You don't see my screen?
Oh, it just popped up.
Oh.
That's right skew, right?
Okay, so yep, that's right skewed. So now, think about the characteristics of a box plot that is right skewed. What are you looking for?
Is Q2 closer to Q1?
Q2 is closer to Q1. Yep. And what else? What do we know about the whiskers?
The whisker to the left is longer than the whisker to the right. Right?
The whisker where?
The whisker that's on the left side is longer than the one on the right, right?
Nope. Remember, the tails match.
So the whisker on the left is longer than the right. Wait, did I just say that?
Oh, you said it the other way around. So which number is it? Which number do you choose?
I don't know. Wait.
All right, so remember, lower half, Q1, Q2, Q3, upper half.
So it's not one.
This outlier, Q1, Q2, Q3. Here, minimum, Q1, Q2, Q3, maximum. Here, minimum, Q1, Q2, Q3, maximum. So you said that you need Q2 to be closer to Q1. So which one is that? I agree with your characteristics. Just match it up.
Is it 2?
Nope, because look, two has this outlier right here. So we know it can't be 2 because there are no outliers. All of the data is together. I know, Mama. What you say, Mom? Right there. I know.
Ow, my stomach, it hurt. So is it 1?
Q2 is closer to Q3. Nope.
Why I look like that? I'm confused.
All right. Look, Des, take this and turn it. Turn it.
It's full.
Clockwise. Turn them all clockwise. So take the top, turn it to your right one time.
So you said Q2 supposed to be closer to Q3?
No, Q2 should be closer to Q1.
So it's 4.
Yes. Oh, dang. Yes. So A is 4. All right, look at B. Now again, critically analyze B. What do you see in B? And remember, I told you about outliers. So anything that is not connected to the main body of the data is an outlier, be it in front, meaning it is much less, it's less than the minimum value of the bulk of the data, or it could be to the right, meaning it is much more than the maximum value in the data set. So B, we need to look for something that denotes an outlier. So which one would that be? We only have 1, 2, and 3 to choose from. I know, boo. Whisper it in her ear.
Hold on, I'm gonna look at the screen in a second. I'm changing the poopy butt.
Oh, okay. How'd you do? You want the broom to clean off your car? Or you got the... I told you to push it. Don't pick it up. Oh.
Now repeat that again, Richard.
That's too much. I'm only at the sidewalk.
Take it off the front of your car
I
first.
should have muted that.
Your engine. You start your car up. All right.
Kick that, so what you doing?
Okay, so my question was, all right, so my question is, we looking at histogram B. So I said in histogram B, first of all, let's critically analyze what we see. And I said, remember, an outlier is something that is some data that is not connected to the main body or, of the data. So looking at B, and I said we only have choices 1, 2, or 3.
It's not 2.
It is 2. And the clear giveaway was this X right here. The outliers, depending on the author of whatever you are reading, the outliers are either marked with an X or, like in our example before, sometimes it's marked with a small circle. Okay, so yep, so B is 2. So now let's look at C. What shape would you say is the distribution? Left skewed, right skewed, or symmetric?
It is right skewed.
The skew matches the tail.
Hold on. It's left skewed.
Right. So it's left skewed. So now we only have choices of 1 and 3. Which would you figure matches C?
1.
Absolutely. Because again, we see, and again, if you need to turn it, you're going to have to turn it in your head one clockwise. But you will see that, excuse me, the left or lower whisker is longer than the upper whisker or the right whisker, and you see that Q2 is closer to Q3. So, yep, C is 1, leaving D to be 3. And again, D is, again, when we talk about shape, is it left skewed, right skewed, or is it symmetric? Just talking shape.
It's symmetric.
It is symmetric. So if we split it right down the middle, we can fold that over. Left side looks exactly like right side. Those would be the same characteristics we would look for in the box plot. Voila. So D matches 3. Okay, so again, critically analyze. What do you see? Okay, and then look for those same characteristics in the box plot. Okay, so now let's talk. Hello. All right, so your assignment was cool down 3, and you are merely answering the question, which measure of center should I use? Now, if you look back in your notes, when we began to talk about the shape of distributions, you should be able to complete this cool down 3 with no problem. On here, I do have it's due by Friday, but I will push it to Monday just because next week is our last week, and we will, close up this unit. So when we come back, we'll be able to move on. So again, remember, the 3 measures of center are the mode, that which happens the most or occurs the most, the median, the value that splits the data in half, 50-50, not necessarily in equal parts. Not equal parts, not necessarily in parts that look the same. Because you can see in this diagram alone, 50% on the left side looks like this, but 50% on the right side is kind of a little more spread out, but it's still 50%. Okay? And that's what we have to remember when we talk about the median. It merely splits the data in half. Okay? Let us not think about the look or the appearance of the distribution. We are merely looking for 50%. And then the mean. The mean is the mathematical average or the arithmetic average, okay? And you see that it is balanced, okay? So that's the task. So now let's look at the cool down itself. Oh, goodness. Oh, because I was somebody else. I was going to say, what is that? Stop viewing as him. Oh, some people have been doing some things. That's a good thing. Excuse me. All right, so here is the cool down. So again, when you look at histogram E, What characteristics do you see? You should see. You have some outliers in the 50s. The bulk of your data is happening in the 60s and the low 70s. And then you also have some data back here in the 80s. So when we go down to the box plots, we are looking for 3 outliers in the 50s. We are looking for the bulk of the data to be in the 60s and the low 70s. And then we are looking for some more data in the 80s. So again, critical analysis says that that would be histogram number 4. So I don't know how you want to note it. You can either click under the histogram itself, space over, put the Roman numeral, or you can write the graph and the Roman numeral. Okay, so that is your task for the second cool down. You are merely critically analyzing the histograms and matching them to their partner box plot at the bottom. And again, I will have lab this afternoon. If you need to come and talk about it and check it out, I will be available. Now, the current cool down is cool down 3. And here's what cool down 3 looks like. I know, Mama. I saw that before. All right, so in this cool down, they say for each distribution below, answer the question, which measure of center should I use to best communicate the data? So again, you are speaking to the shapes. They told you what the shapes are. The first histogram is symmetric, and it tells you here that the mean is equal to the median. And the second one, it is skewed left. The mean is in that burgundy color. The median is in blue. Same for the last graph. It is skewed right. And again, the median is in blue. The mean is in the burgundy color. And again, you are merely answering the question. Given each data set and looking at the shape of the distribution, which measure of center should be used to best communicate the data? So that's what you're going to write. You will answer it. You can put the answers at the bottom. So symmetric, what would be the best measure of center? Skewed left, what would be the best measure of center? Skewed right, what would be the best measure of center? That is what they are asking you. You should be able to find those answers in your notes. You can always go back and look at the recordings of the class. Okay, so it is simple as that. And again, like I said, it will be due on Monday. I am going to post an announcement on Summit for the class so that you remember what is due. All right, I'm going to stop my share. Hey, Ike, how you doing, my love?